In this video, we're going to have a look at the question, how to design a scientific experiment. I want you to imagine that we've got a dispute between two people, and the dispute is this. Does a person who is wearing a black shirt, say a black t-shirt out in the sun, absorb more heat from the sun than somebody who is wearing a white shirt? So here we've got a black shirt and here we've got a shirt. Now, how do we design an experiment to test that idea? Well, when we're speaking of an experiment, one of the first things that we do have is what we call an aim or a purpose. So the aim in this particular experiment is to discover, does black absorb more radiant heat from the sun, than a white colour? So that's our aim. Now once we have decided what the purpose of our experiment is, the next thing is to come up with what we call a hypothesis. Now a hypothesis is an idea, it's a statement, that is, it's a sentence. It's an idea that we are going to test. So in this particular case, the hypothesis might be black absorbs heat more readily or more easily than white. So that is our hypothesis. Now you can see that there is a slight difference between the aim and the hypothesis. This hypothesis is what we think might be true. It's a statement. This can be a question. Our hypothesis is a statement. Now we've got to design the experiment. Well, what do? Do we get two people, one dressed in a white shirt and another one in a black shirt, and get them running out onto the tennis court in the sun to see which person gets hotter? That would not be terribly reliable. We need to design experiments that are going to be reliable. So what we might do is get perhaps two cans, two drinking cans, and with those drinking cans, soft drink perhaps, fill them up with water, use a thermometer, paint this one black, this one white, and leave them in the sun perhaps for say 15 minutes, and then check the temperature. Now when we're doing that, what we need to look at and understand in this experimental design is the idea of variables. Now, a variable in a scientific experiment is one that is a factor that is going to affect the experiment. So a variable is something which changes. So variables change. And we've got things here, a number of things which are going to change. First of all, the temperature. So the temperature in this particular case, because we are looking to see how it changes, this is called a dependent variable. What we're changing at the same time is the colour. Now, we're only just testing two different colours here. So our two colours here are black and white. The two colours that we have here, the ones that we are changing to see what happens to this, we call these ones here independent variables. So the colour is the independent variable. We are changing this colour, this factor, it's changing, so it's called a variable. We're changing it to see what happens to the temperature. So the temperature is the dependent variable. The colour that we are changing is the independent variable. Now there are all sorts of other things which can affect the outcome of our experiment. These factors which can change, so they're variables, we have to keep the same. And those variables that we have to keep the same are called controlled variables. We'll have a look at some of those. So these controlled variables are factors that can change the temperature or could have an effect on the temperature, but we have to keep them the same. So let's think of some things which we would have to keep the same. Perhaps the level of the water. So the amount of water in the can or in the cans. Can we think of other ones? Perhaps the shape of the cans. If we had them different shape, that possibly could affect the rise in the temperature. So perhaps there are others we could think of. What about the time in the sun? Now if we had them different times, at different times in the sun, or if we had, say, one can in there in the sun for 10 minutes and another one here for half an hour, well, we could well expect that to affect the results. So we have to keep those the same. Now there are other factors as well, the time of the day and so on. We won't go through all of those. So if these variables are not controlled, the experiment we would have to call invalid. It's not a valid experiment. So a valid experiment is one which is going to give us the answer to our aim, the question. An invalid experiment is one which is not. So validity is a very important aspect of experimental design. Let's now imagine we've got some results. So let's imagine after 30 minutes in the sun, the temperature in the black can has perhaps risen to a temperature of 36 degrees Celsius. And this one a white one, has risen to, let's say, 30 degrees. Now, we can represent that on a graph. And the way in which we would do this is to put our dependent variable, this one here, on the y-axis, the vertical axis. So this would be temperature, and we put in here the units, so this would be degrees Celsius. And down here, we would put here colour. When we're creating a graph, we always got to have a label and units. Now here, our colour, and our units, if you like, are black and white. They're colours. So we might have something like this as our result. So our dependent variable goes on the vertical axis, and our independent variable goes along the x-axis or the horizontal axis. So what we've discovered here is that this gets hotter than this one for the same amount of time in the sun. Are we now able to come to a valid conclusion? Now the valid conclusion is this: will somebody in a black t-shirt get hotter in the sun than somebody in a white shirt? Well, perhaps that is a valid experiment, and we could conclude that. But then somebody could argue, no, because this was paint, white paint, black paint on the can, but what we've got up here is cloth. This might be a reason for saying that it is invalid. So, some people could argue, yes, it is valid. Some people might argue, no, it's not valid. I won't say whether it is or it isn't. In my mind, I would say that it is very likely to be true. And I would say that when it came back to our hypothesis, this hypothesis that we had, I would say that when it came back to the hypothesis, that this is evidence that is supporting the hypothesis. Now this is another feature of correct scientific method. In fact, in science, there's no such thing as proof. We can say that the evidence supports this idea. And after a while, there is so much evidence that supports the idea that we say, yes, that's true, that's a fact. But the whole process of science is not proving anything. It's saying, gathering evidence that supports something to be true. So, I would say that this evidence supports the hypothesis that black does absorb energy, radiant heat energy, more easily than white. That is what we would call a valid conclusion. Some might say, as I said, that it's not valid. So we have a valid experimental design, and we have valid conclusions. Two things to keep in mind when it comes to experimental design: a valid design, a valid conclusion. Now, validity is a little bit different from reliability. It's quite different. Reliability means that when we are getting the information, that we know that that information or the data is true. So, for example, here, if I just use my finger to feel how hot it was, or this one here to feel how hot it was, that would not be reliable. The same thing would go up here for our players who are out on the tennis court. If they said, oh yes, look, I'm hotter than he is, that's not reliable. So there's reliability, there is validity, there is also something called precision. Now precision in science is how, I was going to say how precise something is, which doesn't really explain it. But To illustrate this with an example, if I said this was 36 degrees, I could say 36.1052. If I had an instrument which in fact was able to correctly read to that level of detail, this would be very, very precise. So precise refers to the level of detail. So, going back to our experiment, the main ideas when it comes to experimental design is to have an aim, a question, something that we're going to have a look at, what we want to find out, a hypothesis, a statement, not a question, a statement that we are going to test. Then we have an experimental design, we have a method, and we have variables. We have one that we change and another one that we look at. The one that we change is the independent variable. The one that we have a look at to see how it changes is the dependent variable. Then hopefully we can come to a valid conclusion. Well, I hope that helps you in any experimental design that you have to carry out.